Welcome to this workshop on attack surface reduction as a primary defense. A little bit about me before we get started. My name is Dan. I'm the head of security at Intruder, and I run the security research and security engineering teams. My background is as a .NET developer, a security consultant, and a penetration tester. So what we'll cover in the workshop today is we'll do a quick recap on why your external attack surface matters with some examples of what can go wrong if you don't manage your attack surface. And then we'll dive into some practical ways to combat attack surface risk. And I'll present the three key elements that I think you'll need to get started with this. So why does our external attack surface matter? One of the reasons that our attack surface matters so much is that the time to exploit for the big weaknesses that hit can be as short as 24 to 48 hours these days. Your sort of CVSS 9.8s to 10s, the types of vulnerabilities that are exploitable, unauthenticated from the internet. You really don't have much time to patch those before attackers are acting on them. 24 to 48 hours is often not enough time for us to get that patch in place. There are lots of obstacles in our way which slow us down. So that could be time between scans, waiting for scans to complete to actually tell us where are we vulnerable, where do we have this product, are we even using this product? We have to wait for those scans to complete before we even know what to patch. And then patching itself takes time as well. We need to escalate those tickets to other teams. We need to assign a priority and chase those up and make sure that patch has actually been done. And we also run into out of hours limitations as well. Even if we have a 24/7 SOC and teams that work out of hours, typically it will take us longer to patch when those big vulnerabilities hit at inopportune times. So to use an example from last year, one of the biggest weaknesses last year was called tool shell. This was a weakness in Microsoft SharePoint, which is a very commonly used piece of software. And the weakness had an impact of remote code execution. It was a unauthenticated deserialization weakness, which basically means if the attacker could reach SharePoint, then they could simply send a payload which would run code on your server, which is particularly bad for SharePoint because SharePoint is Active Directory connected. So the attacker is really starting in a place that you don't want them already. This one was a bit of a perfect storm because Microsoft published the information about the vulnerability. They made it public on the 19th of July, which was a Saturday. So we hit those out of hours limitations. And yeah, exploitation was already happening. This was a 0-day, meaning that the certain attackers had knowledge of this weakness and were exploiting it before the patch was even available. And Microsoft shared news that they found that certain Chinese hacking groups had been exploiting it up to 2 weeks before they published that information. To wind back and explain why external attack surface matters, this is because there's going to be a very small number of people that are targeted by that Chinese APT. Those are the targeted attackers that are the first to have knowledge of a weakness. But after they're finished, after Microsoft has published that information has gone public. Now it hands over to the opportunistic attackers. They know there's an unauthenticated deserialization weakness in SharePoint, and then they go and investigate themselves. They reverse engineer SharePoint. They figure out where the weakness is. They scan across the internet and they find exposed SharePoints that are vulnerable, and then they exploit them en masse for personal gain. And so this is why external attack surface management is so important, because SharePoint doesn't need to be exposed to the internet. By making sure that SharePoint isn't exposed, we massively reduce the number of attack groups that will realistically be targeting us with a weakness. And yeah, when this happened last year, our own research found real examples of the weakness on the internet, and there were actually thousands of SharePoints exposed at the time. Might surprise some people to learn that, but it's actually very common to be exposing things to the internet that shouldn't be there. So why does that happen? Why do products like SharePoint get exposed to the internet? And kind of the counter question to that is, was the security team at that organization or those organizations, were they even aware that it was on the internet? And to dig into this a little bit more as to why this happens, let's look at some example scan results. This is what attack surface can look like in your vulnerability scanner. So we have some scan results here for 1,000 targets. You can see it found lots of different vulnerabilities, some criticals, some highs, some mediums, and lows. But for the purpose of this argument, we're going to look at the informationals. So in this particular scan, there were 183 informational items, which is quite a lot to look through. And at first glance, they don't look that interesting. So if you take the top one there, web application firewall detection, this scan ran from the internet. It ran from a perimeter perspective. So you would expect to see a web application firewall there. That's where it's intended to be. It's meant to be an edge piece of software. It's one of the first things that you hit. So detecting a web application firewall is absolutely normal. And I would 100% agree that that's an informational. But when we dig a little bit further into these 183 informationals, we find that some of them are actually a little bit more interesting and perhaps shouldn't be an informational at all. So the obvious one there is Microsoft SharePoint server detection. So this could be why some of those organizations, some of those thousands with SharePoint on the internet, have it on the internet because it's hidden in their informational scan results, and perhaps they never review their informationals. If we look in a little bit more detail, we can see that hidden in those informationals, there are some interesting results, which actually show us certain pieces of software that shouldn't be on the internet, and perhaps they shouldn't be informationals at all. MySQL server detection, PostgreSQL server detection, databases should only be exposed to the application and not generally exposed to the internet, because for the same reason, if a 0-day gets found in Postgres, then those opportunistic attackers are going to have a much easier time exploiting your systems, and you're going to have much less time to patch. So that's a recap of the attack surface problem. So now we'll dive into attack surface reduction and how we can use it as a primary defense rather than a distant security principle. So 3 parts to this. The first is asset discovery. We need to use asset discovery to discover shadow IT assets before we can start reducing our attack surface. The second part is we're going to do proactive attack surface reduction to then reduce that attack surface that we've defined. And finally, we're going to deploy continuous scanning and alerting. So the purpose of asset discovery is to find shadow IT. Now, shadow IT is a term that we use to describe the unknown assets within your organization. These are the targets that you are responsible for protecting, but you aren't currently scanning them. So they're the assets you don't know about, but you should know about. Shadow IT is inherently high risk. It's kind of high risk by definition, because if we don't know what's on it, it could have critical and high weaknesses that have been sat there for months, and there's nothing we can do about it. So, we're in the dark, they're in the shadows. So it's clearly a high risk set of assets and not a good thing. Shadow IT also grows over time naturally, especially in cloud environments. Nowadays, you can create new infrastructure in minutes, probably even seconds in a cloud environment. So we need to make sure that our VM program is covering those assets as and when they get created, so we can start scanning them and make sure that they're secure. So we're going to use asset discovery techniques that I'll dig into in a second to define our attack surface. And this is effectively actually growing our attack surface. Contrary to attack surface reduction, we're actually going to have to grow our attack surface first, because we can't reduce what we don't yet understand. And if we don't get on top of shadow IT, I've got a meme to explain what happens. One of my favorite things to do is to describe and explain the meme. So this is us in the middle there saying this is fine while the whole world of shadow IT burns around us. So we don't want to be like this dog, ideally. So what can we do about it? In terms of practical asset discovery techniques, I'll start with integrations, because I think integrations is the most important facet to have in place. We want to integrate with everything which is a source of our assets, of our targets being IP addresses, domains, etc. We want to be in a position where a new asset gets created and then it gets ingested into our VM platform automatically and instantly. So in this way, we get a handle on the shadow IT that's being created, especially in our cloud environments and DNS providers. These are probably our main primary sources of asset information, so that when new IP addresses get created in a cloud environment, when new domains get registered with A records and DNS providers, we're automatically ingesting those and scanning those hosts from a remote perspective. CDN's also a good source for this. And integrations of the 3 asset discovery techniques I'm going to describe today, integrations is really The most important one, because we have the advantage over attackers here. The other two techniques that I'll describe, attackers can do it as well. So we need to leverage that advantage over attackers and make sure that we're using it. So that's integrations. And yeah, the second technique is something that attackers can do. So it's something that we should be doing as well. This is subdomain enumeration. There's two types of subdomain enumeration, active and passive. With each type, we're going to start with an apex domain or a root domain. In this example, myorg.com. And we're going to take that apex or root domain and we're going to try and discover all of the subdomains that are associated with it. This is important because you might not have been able to integrate with all your DNS providers. There might be DNS providers or cloud environments which you don't know about because you're a sprawling organization or you've just made an acquisition, or there are many reasons why there can be domains or subdomains that we don't know about. So subdomain enumeration is important in that respect. An example of active subdomain enumeration would be active subdomain enumeration is basically a type of brute forcing. So we feed into a tool a list of words that could be a subdomain. In this case, API and files are two that we found. So we feed in a long word list, which includes the word API and the word files. We do a DNS lookup on each of those, and the ones that spit out an A record that's pointing at something, we know that that's a host. We know it's ours because it's a subdomain of the apex domain we fed in. We know it's pointing at something because there's an A record, and that's the output of active subdomain enumeration. So we can reach subdomains like API dot and files dot that perhaps we didn't know about. But really, the more important one here is passive enumeration, because active enumeration has significant limitations. As with any brute forcing, it takes time and it relies on guesswork. So if we don't have API, or if we don't have files in our word list, we're not going to find those subdomains. And realistically, a lot of the subdomains that we're looking for are going to be much more difficult to detect. So moving on to the passive example, we can see that we found dev-app-monitor-3.myorg.com, which is a much more typical type of subdomain naming convention that you'll find, which realistically brute forcing is not going to detect, because we're not going to have that in our word list unless our word list is incredibly long, and then it would become prohibitive to detect it, because we'd have to be running that scan for many days or months. So we can use passive enumeration to find subdomains like this. Passive enumeration leverages internet-wide scanning public data sources. Think of services like Census, Shodan, Fofar, etc. There are plenty of scanners out there that are scanning the whole internet constantly, and once they're finished, they start again, and they're storing sources of domain names. So it becomes simply a case of doing a lookup. Basically, we look up everything that has star.myorg.com, and we get the results back. And a key passive resource that most passive subdomain enumeration tools will leverage are the certificate transparency logs. The certificate transparency logs is a public ledger of certificates which have been registered with a certificate authority, and that's real time. So as those certificates get registered by developers in your organization, those certificates will get registered to the CTL logs. And then we can use passive techniques to search through them and find those certificates. And that's how we discover certain subdomains like dev-app-monitor-3 that are more difficult to find. And it's a really useful source of information which attackers are using against us. So there's really no excuse for us to not to be doing the same. Two recommended tools for this. I recommend OWASP's AMAS for active enumeration, and probably the best tool for this is Subfinder. Both public and freely available on GitHub. And Subfinder is what I'd recommend using for passive enumeration. So that's subdomain enumeration. And the last asset discovery technique we're going to think about is how to find unknown cloud providers. So let's assume our main cloud house or cloud houses, most likely AWS or Azure or GCP. Let's assume we've covered those by integrations. Let's assume that we've found all of those accounts across our organization and we've integrated those with our VM scanner. What about niche providers? It might be against our security policy to use any other cloud provider other than the ones that we've sanctioned, but perhaps someone's doing it anyway. As a security team, we want to find that out if that's happening and get a handle on it and either shut it down or integrate with that cloud provider as well. This might be a bigger problem than you'd think, because I found this set of statistics on the market share of various cloud providers. The top three are not so surprising. But what was more alarming to me was this other section at the bottom, which represents 24% of the total market share of cloud computing. And even before we've got to other, there's cloud providers in there that are more niche and perhaps you wouldn't even think of that someone in your organization is using. So who knows what's out there and who's using some of these other cloud providers. So we want to make sure we get handle on those so that we can discover those, because that's effectively shadow IT if we're not integrating with those systems too. So we can discover unknown cloud providers. There's a very simple playbook for how to do this. You take an input of a full list of your domains and subdomains. So this could be from your DNS providers. You've downloaded that list. You could also include the output from your subdomain enumeration and get a full list of domains and subdomains. If any one of those domains and subdomains points at one of these unknown cloud providers, then you're in luck, because we can automate doing a simple DNS lookup on those domains to get the IP addresses. Then we'll do a whois on those IP addresses, and we're going to store the net name and the organization attribute. These are the attributes that basically say who owns that IP address. And for most cloud providers, they don't hide that information. They actually freely say who they are, because it's kind of just part of their modus operandi to do that. They tend not to hide that whois information. So we're going to do a DNS lookup on that dev app monitor 3 subdomain that we found. It points to this IP address, 178.79, etc. We'll then do a whois on that IP address, and we find the net name is linode-uk. Might ring a bell, but if not, we'll do a quick Google on that. And we find that Linode is an old cloud provider that has since been bought by Akamai Cloud. So now we know that a subdomain, which is a subdomain of our Apex domain, so it's something that we own, is pointing at Linode, which is now Akamai Cloud. So we know someone in our organization is using Akamai Cloud. Now, if we haven't integrated with Akamai Cloud already, this should be alarming to security teams, because now we have recourse to try and find out who's using Akamai Cloud, ask around within the business, try and find out. And if that fails, we can also even contact Akamai Cloud support, ask them who our organization signed up, who's the contact, or contact our finance team about it, who will probably have records of us paying them. And we should be able to find out who's using Akamai Cloud and either shut it down or integrate with it. So that's the three main parts of asset discovery that I recommend implementing. And now that we've grown our attack surface, it's time to proactively reduce it. So our goal with proactive attack surface reduction is that we have nothing on the internet that doesn't need to be there. We're going to proactively take those services off the internet. We don't want to be scrambling when that next big vulnerability hits, like the next tool shell vulnerability in SharePoint. We want to have already put SharePoint behind a firewall so that we have more time to patch when that happens. And so on and so on and so on for every product out there that we have exposed to the internet that doesn't need to be there. And in this way, we're going to treat attack surface reduction as a primary defense and not just a distant security principle, which we know about, but we actually don't do anything about. There are two parts to this. The first part is detection capability, and the second part is making sure that we actually prioritize doing those fixes. So detection capability, we need to turn this on the left, again, a list of informationals, and we need to turn it into this. So we need some kind of process that pulls out, underscores or red lines those informationals that we actually treat as a bigger risk than that and turns them into an issue with an actual risk. So on the right, you can see that Microsoft SharePoint being exposed has been given a medium risk instead of an informational. Because it's something as an organization we should treat as a risk when we detect it on the internet. And we need to automate this. There's three kind of key parts to automating this. So First, we need to define a list or a database of scan results, whatever our VM scanners are. We need to create a list of IDs of those scan results, which we deem an attack surface risk. So one of them would be Microsoft SharePoint is exposed to the internet. Then we need to process the results. Whenever we run a scan, we need to ingest those scan results, check those results for our defined issues from step one, and then downstream create tickets for those, so to make sure that they don't get lost. So we found Microsoft SharePoint exposed to the internet. What are we going to do about it? And then thirdly, maintain. We need to make sure that we don't forget to maintain our lists from part one, because new detection checks, new pieces of software are getting created and used all the time. So that list is not just a one and done. We need to maintain it and make sure that we keep track of new detection checks, and we decide which new checks are attack surface risks. But luckily, most good external attack surface management platforms will do this for you. But if you're not using one, these are the steps you need to go through to automate it yourself. And then prioritization is the second part of proactive attack surface reduction. We need to make sure we don't get stuck in what I call the firefighting trap. Firefighting trap is where we focus on patch management because we've got a lot of critical and high weaknesses to fix. And by the time we're done patching our criticals and highs, we've run more scans and there are new criticals and highs. And we rinse and repeat, and we never get out of that cycle. And we never find time to do more strategic security work like attack surface reduction, which is important because in the long run, doing things like attack surface reduction will reduce the number of criticals and highs you have in the future and get us out of that firefighting trap, so that we're not just constantly trying to patch the latest critical and we don't have time for anything else. And remember, attack surface reduction issues, they have no CVE, they have no CVSS score, they don't have an EPSS prioritization score, and they're not on the known exploited vulnerabilities list. So if these are the metrics we're using for prioritization, that's purely focused on patch management, and attack surface reduction issues are going to fall through the gaps. So we'll make sure that we prioritize having some kind of dedicated time or resource towards fixing attack surface reduction issues. So examples could be something like we spend a defined 2 weeks per quarter where attack surface reduction issues, they get a higher ticket priority for getting fixed. So we can bump them up above some highs and criticals so that they actually take priority in those weeks. Or we could empower a team member and make them responsible for our attack surface, so that they're the ones that are creating those tickets and chasing them and making sure that those strategic changes get done. And then lastly, we want to make sure that we have continuous scanning and alerting in place so that we can get a handle on things that are happening as they happen so that we can react fast. So in a quick example scenario here is someone edits a firewall, they make a mistake and they open it up to the internet. And let's say some sensitive services like remote desktop get exposed. As a result of that mistake, we should ask ourselves first, how do we find out that that's happened? But more crucially, when do we find out about that? We don't want to be waiting till our next monthly vulnerability scan to find that remote desktop has been exposed for that whole month because it happened just after our last vulnerability scan. We want to be finding out the day it happens or very soon after. So we need continuous scanning and alerting for this. We want to do continuous port scanning. Now, the reason I mentioned port scanning over vulnerability scanning is that port scanning is much faster than doing full vulnerability scans, especially when you're scanning many, many thousands and thousands of targets. VM takes time. It's running lots and lots of different checks for many different things, and those scans take time to run. So typically we run VM scans on a slower cadence. Something like monthly is very common, sometimes weekly, but it's very rare that a large organization is going to be able to do any more than that because they'll be running scans that overlap with each other. Scans don't finish before the next one runs, and there's no time to actually ingest the results and act. So it's very common to run vulnerability scans on a slower cadence, and therefore for continuous scanning alerting to find out things that are happening in real time, we can use port scanning instead, which is a lot faster. Ideally, a cadence more like daily will make sense so that you can constantly scan which ports you have exposed to the internet and detect on a recurring basis which ones have been newly opened, which ones were not in the last scan results from yesterday's scan. And then we want to get some real-time alerts on that. So when a new port pops up that wasn't in the last scan, we get an alert where we spend our working day, or where our team spends our working day, be that email, Microsoft Teams, or whatever, that says new ports have been detected. Someone go take a look. DIY solution for this, you'll want to use Nmap. But again, a good external attack surface management platform is going to cover this. So a few key takeaways from today's workshop. Make sure that you have a vulnerability management platform which highlights attack surface issues to you. Make sure you have a proactive policy or a process to proactively fix them as they come up, so we're not just spending our time firefighting. And lastly, let's get continuous port scanning with alerts in place so that we can scan and find things on a regular cadence and find out about things as fast as possible so we can act.